transit of Mercury is just around the corner, and scientists are planning to make observations that are only possible during the rare celestial event. On Monday, the Solar System's innermost planet will appear to glide slowly across the surface of the Sun in a downward-sloping diagonal line. Observers on the East Coast can watch the small dot of Mercury begin to traverse the solar disk beginning at 7:12 a.m. EDT. Here on the West Coast, we'll have to wait until the Sun rises at 5:56 a.m. PDT to catch the transit already in progress. Mercury is so small, about a third the size of Earth, and so far away, an average of 48 million miles, that its journey across the Sun will only be visible with a telescope fitted with the solar filter. Even then, it will appear as a small round speck, about the size of a small sunspot. Even though Mercury is flying through space at an average of 30 miles per second, it will take the planet 7.5 hours to traverse the Sun. Observing the clockwork of our solar system is always thrilling, but some researchers are using the relatively rare transit of Mercury to make scientific observations. On Monday morning, half a dozen scientists will gather at the Big Bear Solar Observatory on the north side of Big Bear Lake to take measurements that are only possible during the transit. Observations are also scheduled at solar observatories across the country. Williams College professor of astronomy Jay Pisikoff said he is particularly interested in understanding a phenomenon that will occur just as Mercury approaches the edge of the solar disk just after 11:30 a.m. PDT. During previous transits of Mercury and Venus, astronomers have observed that the planets appear as a tear shape as they near the edge of the Sun. When the planet is almost tangent to the disk, there is a black joint between the black edge of the Sun and the black edge of the planet, he said. For hundreds of years, this effect was observed during transits of Venus, and astronomers hypothesized that it was caused by the planet's atmosphere. But during a 1999 transit of Mercury, the same effect was observed, even though Mercury has no atmosphere. Pisikoff is hoping to take precise measurements of this phenomenon on Monday to better understand what might be causing it. Andrew Potter, a planetary astronomer at the National Solar Observatory, who discovered the faint signature of sodium in Mercury's exosphere, is also using the transit to do some science. As Mercury passes in front of the Sun, the sodium in the planet's exosphere will absorb a specific wavelength of light, which will show up as a line in a spectrum of light. By looking at the exosphere during the transit, Potter will try to understand the processes by which sodium atoms are released from Mercury's surface. Finally, several scientists will try to see whether they can detect a slight dimming in the amount of light that emanates from the Sun as Mercury passes in front of it. This is the same technique that planet hunters like NASA's Kepler spacecraft use to detect exoplanets around distant stars. In two previous transits of Mercury, in 2003 and 2006, the dimming was too small to be detected. Depending on whether scientists can detect it this time, it could help them better understand the limits of their abilities to detect small planets in other solar systems. The last transit of Mercury occurred in November 2006. The next one will occur in November 2019. If you want to check out the transit online, you've got a lot of options. You can catch the show live on the astronomy website slu.com, or via live streams from the European Space Agency, Sky and Telescope and NASA's Goddard Space Flight Center in Maryland. Anyone wishing to observe the transit directly is cautioned to do so only with the telescope equipped with the proper solar filter.